All right, double angle formulas. So double angle formulas allow us to find just that, the double of an angle. So if we have something like, you know, 60 degrees, I can double that for 120 degrees, and I can find the exact value for those. So using compound angle formulas, we can develop 3 new formulas. Now you might say, we just learned 6 formulas. Why do I have to learn 3 more? Well, these 3 come directly from those compound angle formulas, the addition ones. Because if you have one angle plus another angle, well, that's double the angle. So instead of us adding 2 different angles, like we did in the last chapter, we're going to be adding 2 angles that are exactly the same. So we can get these by using the addition compound formula from 7.2, where both the angles are the same value. Use the compound angle formulas from 7.2 by using theta for both angles. One of the principles that we're going to be applying, especially in the cosine section, is the Pythagorean identity that you learned in grade 11, which said sine squared theta plus cos squared theta was equal to 1. So let's go through these. So first one, sine of 2 theta. Well, that's just simplified to sine theta plus theta. And in the last section, we learned that when we're adding 2 angles like this, we use the sine addition one, which was sine theta cos theta plus sine theta cos theta. Right? Remember, it was like our first angles were here and here. Our second angles were here and here. It just happens to be theta. So when I look at what we're left with, we have the exact same thing to start and end. So I add them, 2 sine theta cos theta. And that's our first double angle formula. For sine double theta is equal to 2 sine theta cos theta. Let's keep going along. We'll look at the cosine. So cosine double angle, well, that's, we know, cos theta plus theta. Cosine double angle, actually give myself a little bit more room, was cosine theta, first angle, cos of the second angle, minus sine of the first angle, sine of the second angle. So when I multiply cos times cos, I get cos squared. So that just becomes cos squared theta minus sine squared theta. That's its identity. I'm going to fix that so you can see the squares. Now I can apply the Pythagorean identity to each of them to create 2 formulas from these. So I know that cos squared theta is equal to 1 minus sine squared. So if I move sine over, so I'm going to write that as 1 minus sine squared theta. That could be like cos squared minus sine squared theta. So if I work with these, I can subtract the 2 sine squared thetas, which gives me 1 minus 2 sine squared theta. So that's one formula that you can derive from it. So it's also equal to the cos double angle. And we can do the same thing for the sine. So I know that sine is equal to 1 minus cos squared, right? If I brought cos squared over their side. So I'm going to do that from this one. We're going to have cos squared theta minus 1 minus cos squared theta. And when I distribute that negative through, we get cos squared theta minus 1 plus cos squared theta. So if I add those 2 cos squared thetas together, we get 2 cos squared theta minus 1. That's also derived from that original formula. So all 3 of those can be thought of as being cos double angle formulas. So depending on what we're given, you might use one over the other. So like, for example, if a question gave me cos squared and sine squared, I can just substitute into that formula. If a formula just gave me sine squared, I can put it into the second one. If it just gave me cos squared, I can put it into the third one. Doesn't really matter. Now, how about tan? So I know that its formula tan theta plus theta, had on top tan of the first plus tan of the second angle, all over 1 minus tan of the first times tan of the second. So if I simplify that, on top I'm going to have 2 tan theta, all over 1 minus tan squared theta, because they're multiplying. And that would be the double angle for tan. So what I'm going to do is I'm going to consolidate this all together into one simple place down below, because we're going to be using those formulas. So I'm going to use a nice special color here. 2 sine theta cos theta. That was our double angle for sine. Our double angle for cos, we had multiple. We had cos squared theta minus sine squared theta. Or we had 1 minus 2 sine squared theta. Or we had 2 cos squared theta minus 1. Any of those are fine. And finally, for tan double angle, we had 2 tan theta all over 1 minus tan squared theta. So those are the new formulas that we have. They're just derived from the compound angle formulas that we learned in the last lesson. So we're going to go through some examples. So first one says, given that sine is equal to 3 over 5, and we are in the second quadrant. Second quadrant here, we have theta as our angle. We know that in the second quadrant, well, we have a triangle created here. I know that the opposite side is 3, and I know that the hypotenuse is 5 based on our y over r that we know from sine. We can calculate the bottom using that the Pythagorean theorem. 5 squared is equal to 3 squared minus x squared, or plus x squared, let me say. We get 25 is equal to 9 plus x squared, and when I solve it through, we're going to get x is equal to positive or negative 4. So since we're to the left, we're going to assume that's minus 4. So how is that useful to us? Well, if I'm looking for the sine double angle, I'll use blue. I know that sine double angle is 2 sine theta cos theta. Now I'm going to fill in our values that we know. I know that sine theta, well, it gave it to me, it was 3 over 5, so it's going to be 2 times 3 over 5. Cos theta is negative 4 over 5, and I know that from that triangle. And when I multiply that through, I'm going to multiply all the tops. 2 times 3 is 6, 6 times 4, negative 24. Multiply the two denominators, 5 times 5, 25. That's our value of sine double angle x, or theta, because we can call it that. For some reason I called it x. Same goes for cos, I'm going to call it theta as opposed to x. So let's keep going. Cos double angle theta. So we still have our triangle that applies in this case because it's the same question, still the same theta. I'm going to decide which one to use, whether I should use cos squared theta minus sine squared theta. That's fine. I can use any of them. Let's use this one just because we used cos and sine in the question before. I know cos was negative 4 over 5. But remember, it's squared in this case. That means you square the top and bottom. Sine, we figured out, was 3 over 5. And when I solve this through, when I square the top, you get 16 over 25. Sine is also squared. You're going to get 9 over 25. And when I subtract those ones together, 16 minus 9, we get 7 over 25. It didn't matter which formula I used. Suppose I chose a different one. Suppose I chose, let's take 2 cos squared theta minus 1. Right? The other double angle for cos. Had I done that? Well, 2 times cos squared, well, that was minus 4 over 5. We knew that. Minus 1. If I solve this, we get 2, 16 minus 25 minus 1. If I multiply it, I'm going to get 32 over 25 minus 25 over 25, right, minus 1. When I subtract those, I also get 7 over 25. Same answer. Doesn't matter which one I use. And I'd get the same if I used the third cos double angle formula. So it didn't matter. But that's how we solve those ones. So I'll keep rolling along here. If cos theta is equal to negative 3 over 5, find cos 2 theta. So I can decide which one to use here again, right? I can decide to use cos squared theta minus sine squared theta. I can use 2 cos squared theta minus 1, or I can use 1 minus 2 sine squared theta. Now, based on me only being given only being given cos, I should probably just use this formula here. So I'm going to plug that in. So we're going to put in 2 cos squared theta minus 1. Well, cos theta is negative 3 over 5, so negative 3 over 5 squared minus 1. Negative 3 over 5 is 9 over 25 minus 1. 18 over 25 minus 25 over 25 gives me negative 7 over 25 for that one. Had I wanted to use one of the other formulas, we could have gone through a few extra steps. We could say, well, I know that cos is negative, so cos is going to be in either the second quadrant or the third quadrant. I'm not sure which one it's going to be in. We know that if that's the case, we have our triangle like so. I know that our x value in this case is negative 3. I know my hypotenuse is going to be 5. Now, for my y value, we don't know what sign's going to be. I don't know if it's going to be, if I use Pythagorean theorem, I don't know if it's 4 or if it's going to be the negative 4, because I get both answers. So I would have to solve those ones through. It wouldn't matter because we end up squaring them anyway. So like, for example, in this case, 1 minus 2 sine squared. So no matter whether I'm talking about this angle here or this angle here, I'm going to have 4 over 5 or negative 4 over 5, but I'm squaring it. And when I solve it through, you would get 16 over 25, 1 minus 32 over 25. Get common denominators, 25 over 25 minus 32 over 25, and we still get negative 7 over 25. So a little bit of extra work. However, we ran into a little bit of a problem. We didn't know whether it was going to be positive or negative. Didn't say what quadrant the question was in, but it didn't matter because it told me cos theta is equal to negative 3 over 5. So I might as well just use the formula that has cos in it and avoid all those problems altogether. So I didn't have to do all this stuff on the side. But didn't matter. It worked out to be the same answer. All right, let's look at the next one. Let's suppose we have some angle, we call it beta, lies in quadrant 2. So that's some good information for us. So I'm going to draw that out. Then it tells me tan B is equal to negative 4 over 3. So I'm going to make this triangle here. Let's use different color. I know tan is negative 4 over 3. Now, one thing we know is that it could be negative 4 over 3 or 4 over negative 3. That's the thing with a fraction when it's negative. It could be on top and could be on bottom. But since it's in quadrant 2, I know that the opposite side is going to be positive because this is above the x-axis, so the y value is going to be positive. I know it's going to be 4, and this side here is going to be negative 3. Now, if that's the case, I can find out my hypotenuse. Negative 3 squared plus 4 squared is equal to r squared. And when I solve that through, spin the same values throughout, we get 25 is equal to r squared. When I square it, it gets positive or negative 5. But the radius is always going to be positive in this case, or in all cases. It's never going to be negative. It's always the distance from the origin to the end. So let's use what we know now, because I know this now, all three sides. I know sine beta, cos beta, tan beta, and all of the reciprocals. So this one asks us to find out sine 2 theta. Well, I know that that is 2 sine theta cos theta from our formulas above. Now, in this case, our theta is angle B. So we're looking for B. So it's really double angle B. So I'm looking for sine B, cos B. And let's calculate them. So sine of B is 4/5. Cos of B is negative 3/5. And when I solve them through, multiply all across the top. 2 times 4 is 8 times negative 3, negative 24. 5 times 5, 25. We have our exact value for sine double angle. Also asked us to find out cos double angle. So it doesn't matter which one we use. Cos beta minus sine squared beta. We can use beta. So cos is negative 3/5, but remember that's being squared. Minus sine, which is 4/5, and that's also squared. So we get 9/25 minus 8/25, which is 1/25. We got our cos double angle formula worked out. So now these ones say expressed as a single trig function. So we might see the formulas in different ways. Now this one here kind of looks like the double angle for sine, but it's usually like this. I see that 12 in front. I want it to be 2. So what we can do is factor out 6. Put it into a form that we're used to seeing. And I know that what we have in the bracket is equal to sine 2 theta. And that would be the answer. Right? Just 6 times sine 2 theta. Let's keep going along here. B. Well, that one looks like cos double angle. So I know that this is cos double the angle that we're given. What's the angle? 3/2 theta. So in this case, 2 can be distributed inside, right? It's part of the angle. What's going to happen is the 2 and the 2 are going to cancel out. We're just left with 3 theta. Keep going along. This one here also looks like cos. So this is cos double angle. What is the angle? Well, it's 7 theta/2. So if I simplify that, it just becomes cos 7 theta. All right, so we're just recognizing the form that they're in. This one here has tan. Normally what we see is 2 tan x or theta or whatever variable we're using for the angle, and usually it's 1 minus tan squared x, or angle, whatever it is. Now, how do I get that? Well, really what's going to happen is I'm going to have to factor out 8 from the top. I'm going to have to factor out 8 from the bottom. So let's do that, because I want it to be 2. If I factor out 8 from the bottom, I'm going to have 1 minus tan squared x. What's going to happen is these 8s are going to cancel out. It just leaves me with the original double angle formula for tan. The angle in this case is x, so it's 2x. Right? Or it could be theta, it could be any variable, really. Now, let's keep going. So one thing that you might have been noticing throughout this is that any time that we're given one of the ratios and the quadrant that it lies in, we can find out the third side by using that Pythagorean theorem, which allows me to find out any ratio no matter what. So we're going to try to apply that here. It says if cos theta is equal to negative 3 over 5, but in this case, it does not tell us what quadrant we're in. All the way from a full circle, 0 to 2 pi radians. Determine the value of cos theta. And we're also going to find out the value of sine 2 theta. I think I said cos theta, but it's cos 2 theta. And we're going to find sine 2 theta as well. So there's two cases. If cos is negative, right, using the cast rule, I know it's either going to be in quadrant 2, or I know it's going to be in quadrant 3. So I'm going to have to take both those into account. I'm going to break it down from quadrant 2 first, and then I'm going to use quadrant 3 next. So let's take quadrant 2 to begin. If we have our terminal arm ending in quadrant 2, something like this, I know cos is negative, so that means the adjacent side to the angle is 3, and the hypotenuse is 5, which tells me that this side's got to be 4. So in quadrant 2, I should be able to find out sine 2 theta, because that's 2 sine theta cos theta. 2, well, sine theta from that triangle that's in quadrant 2, or the terminal arm that's in quadrant 2, is 4 over 5. Cos is negative 3 over 5. So when I multiply all those ones through, we get negative 24 over 25. How about the cosine double angle? Well, I can use any one of the 4, or of the 3, I should say. Cos of that triangle in the second quadrant is negative 3 over 5, right? Adjacent over hypotenuse squared, all over sine, which is 4 over 5 squared. Now, when I work through, we get 9 over 25 minus 8 over 25, and we get 1 over 25. So those are my two values for sine double angle and cos double angle based on the information I was given. However, that's only for quadrant 2. How about for quadrant 3? I kind of use the same colors over here. If my terminal arm is here, well, we're in a different situation. What's different is, well, the adjacent side to the angle is still negative 3. The hypotenuse is 5 because it originally told me cos was negative 3 over 5. So that's not changing anything. But the difference here is our opposite side would be negative 4 because it's down below the x-axis, right, to our point. So let's take those into account. So the only difference that we're going to come to is that sine will have negative 4 and tan, but there is no tan that we're finding here. So let's do the same thing here. So this is for quadrant 3. The one above was for quadrant 2. We're doing sine theta, cos theta. Sine in this case is negative 4 over 5, right, for quadrant 3, that terminal arm on the right. Cos is still negative 3 over 5. So when I work through this one, we get positive 24 over 25. So that's a possibility for double angle. If our cos is negative 3 over 5, that's one of our possibilities because it does not tell us what quadrant it's in. It tells us it's just one full circle. So we can only narrow it down to quadrant 2 and quadrant 3 because cos is negative, and those are the two quadrants cos is negative in. And finally, cos. Now this one is going to work out to be the same as what's above because sine is being squared. Doesn't matter what sine is, it still works out to be a positive value. Right, negative 3 over 5 because cos is still the same. Sine is now negative 4 over 5, but it's squared. So we're going to get 9 over 25 minus 8 over 25, which still works out to be 1 over 25. So those are some questions with these double angles. They just flow right from our compound angles. So as long as you know those ones, you'll start to recognize these formulas that you see. There's some questions in your textbook that you can try down at the bottom here. There's quite a few, but most of them are just kind of recognizing what you see. And I would say start to getting to recognize these formulas here. They're going to be ones you're going to be using quite a bit. And I realize there's a lot of formulas in this section, but just keep practicing. The more you write them down, the more they'll get stuck in your head and you won't forget them.